welcome to the case study discussion on thermomechanical fatigue failure in gas turbine blades using design thinking approach. So this thermomechanical problem is arising in the all the gas turbine engines, especially in the turbine blade region due to the high temperature as well as the mechanical operation due to high vibration and rotating parts. So we are going to apply our design thinking of 5 stages: empathy, define, ideate, and prototyping and testing, which help us to understand how this fatigue failure is happening in the turbine blade and analyzing all the engineering possibilities to address this issue, so that we will understand how safely and how effectively we can design the turbine blade and how this Rolls-Royce company is making the engine more effective. That we will discuss through design thinking. So we'll start.
Thank you, sir. When we talk about empathizing engineering, we are not just looking at the machine, but at the people affected by it. In this case, the turbine blade failure isn't just even a technical issue. Airlines had to catch flights, passengers faced delays, and safety concerns and maintenance crews had to perform frequent inspections under pressure. At the core, the turbine blades were experiencing extreme conditions. Very high temperatures combined with mechanical loads during rotation. Over time, this repeated heating and cooling caused expansion and contraction. While mechanical forces acted simultaneously, this combination led to thermomechanical fatigue, where tiny cracks began to form and gradually grew. So, understanding this problem from both the human and engineering perspective helps us realize the seriousness of reliability and safety in aerospace systems.
So every startup and shutdown of engines, the engine experiences thermal as well as the mechanical loads. Thermal loads in sense of while starting the engine, the combustion gets more temperature, and while start rotating, it will act as a mechanical load. So thermal expansion as well as the contraction takes place simultaneously, as well as due to the high speed of rotation, the centrifugal force will act in the transfer direction of the blade. So this will says that how the load of combination of thermomechanical is acting in the empathy, which I clearly explain.
Building on that, the next step is to define the problem. In this case, the challenge is to improve the durability of turbine blades so that it can withstand high temperature and mechanical stress over the long operating cycles. It's just not the high temperature or stress, it's the interaction of both. The blades operate in the environment where the temperature exceeds 1000 degrees Celsius. Also, it operates at the high speeds. So, it creates the complex condition. It leads to accelerate the material degradation. So, the problem becomes how to design the turbine blades so that it can resist the crack formation, maintain structural integrity, and reduce maintenance requirements. Also, all this have to satisfy the aerospace safety standards. So, this is a classical example for multi-constraint engineering.
Yeah, this is the more critical component in the aircraft, especially in the engine. Turbine is a more critical component. So, design aspect as well as the safety aspect, we need to concentrate on designing such component. And also, by looking at fatigue, we need to see how long it will operate in different environments like the thermal region, mechanical region, and also the critical case. That is what the main define we have to make in this case study.
So once the problem is completed, we should move into the ideation process. So where we can explore multiple solutions. Basically, engineers will explore many ways in the ideation process. One of the way for blade performance is choosing the material. So we can choose like single crystal superalloys, which can resist the fatigue. So another way is using the thermal barrier, which will protect the material from the high temperature. And also the cooling system also plays a major role here, because engineers design a small internal package inside the blade, so it allows cooling and protect the material from the high temperature. And also the blade shape also plays a major role, which reduces the stress. So, but nowadays we are using the AI and sensor technology for predicting the failure. So this makes engineers to predict the failure before it happens. So combining all these ideas, we can improve the performance and reliability.
So, great idea. Using single crystal elements which can avoid the crack propagation even though the micro cracks. That is one part by choosing the proper material. And second thing is using AI technology, which we can predict the failures before it gets break or it gets more destroyed. So that is the idea we can
So, good morning, sir. Now we are going to look at the prototyping. So, prototyping is a process after choosing the proper statement. So, in aerospace code, physical model and computation simulations are used. So, in computation simulation, we test the model by analyzing the stress and temperature conditions and other mechanical conditions which can cause failure to the model. So in this case study, we are using the digital grading, where we use the replicate real engine behaviors in virtual environments, which saves the time and process of manufacturing the material without causing the failure.
So here we are taking is what we have digital twinning. Digital twinning both simulation as well as the experiment part. Both simultaneously will look in a virtual mode where we can analyze all the structural and thermal analysis and we can predict the failures. So now we move to the testing case.
So testing is the final stage where design is checked in real or simulated conditions. So engineers test the engines on the ground and in flight to see their performance. So generally methods like ultrasonic and X-ray testing are used mostly to help find cracks and damage in the design. So testing ensures the design is safe, reliable and ready for the real world deployment.
So in this case study we have understood that empathizing a real-time problem, creating and incorporating new AI technology, finding utility methods as well as the virtual method of digital twinning. And with all those things, finally we have to make tuning models in a regular way. So we are using the NDT, the non-destructive method, understanding method. Using and this method we can find out the failures or the fatigue of the engines. So this is the how the engineers are used to design thinking to finding the failures of the material. So thank you.